So this is an overview about how to put together a QD. A QD is the way a clinical researcher communicates with the statistical programmer. Uh, because the QD is the primary way of establishing this communication, it's extremely important that the QD be put together in the most formalized and standardized way possible. Because any mistake happening in the QD will probably generate a series of questions between the statistical programmer from the statistical programmer to the clinical researcher, which will necessarily delay the entire process. Which means the more complete your QD is, the faster you will get your results. So the first step for formulating a QD is to go to the CISO site and then click on Research Question Formulation and click on the link for blank QD. By getting the blank QD, you will be able to download a Word document which contains all the main headings for a regular QD. And these headings are the ones displayed in this document. Now, how do you do this? Well, simplest thing to do is simply to go back to the CISO site, still under Research Question Formulation, and look at previous examples. When you click here, you're taken to a page which has a series of QDs that were actually part of real clinical research studies. Let's take a look at this study for computer literacy. And now let's go over each one of the main sections. And again, keep in mind, the sections here are exactly the same sections as here. Okay, so usually what we do is that we simply copy and paste this into a Google document so that it can be shared with the statistical programmer. So let's evaluate each one of them. So number one is the description of the database. So here you should have the name of the database and the time frame when the data were collected. Number two, and this is probably the most important portion of the QD, are the hypothesized conclusions. Now, most research questions in clinical research, not all of them, definitely not all of them, but most of the questions, they involve some type of outcome and some type of predictor. And whenever you create your hypothesized conclusions, you should necessarily state them, if this structure is applicable to your research question, state them using the structure for outcomes and predictors. So for example, in this study, what the study is all about is a number of patients in Durham County. They answered a questionnaire in some primary care clinics, and they answered about their level of computer literacy. And what we're trying to do is to associate computer literacy with some predictors. Okay, so basically the first hypothesis here is that self-evaluation of computer comfort is highly predictive of computer literacy scores. Well, basically, if something is highly predictive, this variable here, computer comfort, is the predictor, and the variable literacy score is the outcome. Notice that as I am putting together the hypothesized conclusion, I'm already marking in brackets the names of the variables. Now, why is this important? It's important because if I point to a variable here as a predictor, later this same variable will have to be present in the list of predictors. And this is what we call the consistency, the internal consistency within the QD. Same thing for the other one. So elderly people, and here the variable is age, have lower computer literacy scores. The outcome is literacy score, but this effect is not present among those with high self-evaluation scores. And here's the variable for computer comfort. And then other conclusions you might have. Now, very important, in every single of the three hypotheses, the literacy score was the outcome variable. So here in the section for outcome variables, I basically list the variable. Now, an important point is that the name within brackets is always the exact same name that is in the spreadsheet or the database. Why? Because you want to make sure that what you are calling literacy score is exactly the same variable that the statistical programmer will find in the database. Second, you list all the main predictors. And again, it's extremely important to ensure internal consistency. If in one of your research questions or your hypothesized conclusions you had a certain predictor, it should be listed here. And the opposite is true. You cannot list any predictors here that are not in your hypothesized conclusions. Okay. Number three, the potential confounders. And the potential confounders are nothing more than variables that can potentially affect or change the level of association between the predictor and the outcome. Number three, or next step, are the actual strata. And here, in this case, age is a strata. Why? Because in one of our hypothesized conclusions, we said that literacy would change across different age categories. We don't have inclusion and exclusion criteria for this study because basically every single patient in the study will be part of the analysis. But if you had any types of inclusion or exclusion criteria, for example, if we wanted to exclude every patient who, for example, had somebody else entering the data in the computer for them, if we think they should be excluded, then the exclusion criteria should say that we're going to exclude every patient who didn't enter the information himself or herself. And then, very important, list the respective variable under brackets so that the statistical programmer can know what you're talking about. Statistical methods and general observations. If you have any observations to make about anything else in the paper or in the analysis, this is the place to put them. And then finally, tables, which actually applies for both tables and graphics. If you have an idea of what your table should look like, you should build mock tables here. So basically tables without results, but basically displaying how you would like the data to be displayed.